Deep inside Minnesota's Judge C.R. Magney State Park, the Brule River winds through the forest along a predictable path. To any observer, it appears to be a standard, healthy river system. That predictability ends at the Devil's Kettle. The river abruptly splits in two. The eastern half flows cleanly over a waterfall, continuing its journey. The western half plunges straight into a massive, yawning pothole and simply disappears. For decades, curious visitors tested this void. They dropped heavy logs, buoyant ping-pong balls, and eventually active GPS trackers into the churning water. None of these items ever resurfaced. A missing volume of water this massive requires an explanation. The most popular theory proposed a complex subterranean tunnel, carving a hidden path through solid rock, draining the anomaly miles away. Observers looked toward Lake Superior, the largest freshwater lake in the world, imagining a secret passage emptying directly into the deep. Without a visible exit point, the pothole remained a geological anomaly. The visual of the water vanishing effectively became the reality. Eventually, the approach shifted from watching the hole to actively trying to track the invisible current. Tossing floating debris into the plunge pool yielded zero data. The core assumption was that if the items didn't resurface locally, the water must be carrying them miles away. The physical reality beneath the rock is a network of jagged, narrow channels. Solid objects like logs and GPS trackers get wedged tight against the stone by the sheer force of the current, unable to pass through. The next logical step for researchers was dye tracing. Hydrologists considered pouring bright fluorescent dye into the pothole to watch where the color emerged, but the Department of Natural Resources ultimately scrapped the idea. This simulation shows why. Any dye introduced into a system churning with hundreds of cubic feet of water per second would be immediately diluted. By the time the water forced its way back to the surface, the color would be practically undetectable to the human eye. Human tracking methods failed because they relied on sight in a geological environment perfectly designed to destroy visual evidence. In 2017, a team of DNR hydrologists, led by Jeff Green, approached the problem with a different methodology. They treated the Brule River as a closed mathematical system. This diagram shows stream gauging. Instead of tracing the path, they measured total water volume at a specific point upstream, before the split. Above the Kettle, flow was 123 cubic feet per second. Downstream, they measured again, 121 cubic feet per second. This negligible difference proves the total mass of the water hadn't changed. The math left one conclusion. The water drops into the massive pothole, forces its way through the bedrock for a short distance, and quietly rejoins the river out of sight. By measuring the visible system parameters on the outside, scientists definitively mapped the path on the inside without ever needing to look inside the void. The 2017 study effectively ended the mystery of the Devil's Kettle. The water never vanishes. But while the water obeys physics and forces its way out of the bedrock, the solid items thrown in by humans do not. Decades of logs, ping-pong balls, and trackers are currently wedged, crushed, and rotting away inside a violently churning labyrinth of stone beneath the surface. The crushing force of the river turns the pothole into a permanent, grinding trap for anything caught in the flow. Solving the Devil's Kettle didn't require a deeper look into the hole. It only required trusting the math of the flow over the evidence of the eyes.